Let's solve this problem. See, the same problem I have just changed the numbers, okay, so that it will give you some more practice. What you can do is you can try this problem by yourselves before watching the video. Fine. They have given that logical address space equal to 4 gigabytes. So what I have done is I have just converted in terms of powers of 2, right? 2 square into 2 power 30 bytes, which is nothing but 2 power 32 bytes. Also they have given that page size equal to 4 MB. So 4 is nothing but 2 square into 2 power 20 bytes, which is nothing but 2 power 22 bytes. Fine. Now they are asking what is the maximum size of the page table entry possible, assuming that we are using single level paging. So in case if we wanted to use single level paging, then it should definitely be true that size of page table should be less than or equal to size of frame, right? That is what I have written. Now what we can do is we can write page table size as number of page table entries into size of a single page table entry, right? Size of a single page table entry. This should be less than or equal to size of a frame, right? Size of frame. And number of page table entries is nothing but number of pages. Fine. See, among these three, do we know anything else? See, this is nothing but we need to compute, right? Size of single page table entry. Do we know the number of page table entries? We don't know that. They have given size of frame, right? They have given size of page, right? It is 2 power 22 bytes. Now, if page size equal to 2 power 22 bytes, then frame size should also be 2 power 22 bytes, right? So, I am writing this 2 power 22 bytes. Fine. Now, I am going to take this as E, okay? Size of single page table entry as E. This is what I need to compute. Now, in case if I can compute the number of page table entries, then I can calculate the value of E easily, right? So that is what I should be doing. Using the given data, I should compute the number of page table entries. See, number of page table entries is equal to number of pages, right? Because for every page, we maintain a page table entry. Now, can we calculate the number of pages? Number of pages of a process is nothing but logical address space of the process divided by size of a single page, right? Logical address space is total size of the process divided by page size will give us the total number of pages our process has. Fine. They have given logical address space as 2 power 32 bytes. Fine. They have also given the page size as 2 power 22 bytes. Fine. So 2 power 32 divided by 2 power 22 is nothing but 2 power 10. Bytes and bytes are getting cancelled, right? So 2 power 10 pages is what we have in our process, okay? So if there are 2 power 10 pages, then the number of page table entries will also be equal to 2 power 10, right? So 2 power 10 into E should be less than or equal to 2 power 22. Now what I can do is I can bring this 2 power 10 here, right? So E should be less than or equal to 2 power 22 divided by 2 power 10, right? So this bytes will remain as it is, right? This bytes will remain as it is. This 2 power 10 is number of page table entry, so it will not have any unit. So 2 power 22 divided by 2 power 10 is 2 power 12, right? So E should be less than or equal to 2 power 12 bytes, right? So 2 power 12 bytes is nothing but E should be less than or equal to 2 square is 4 KB, right? So size of a single page table entry should be less than or equal to 4 KB. Now in case if it becomes more than 4 KB, then we cannot use single level paging, right? We might have to go for multi-level paging. So what is the maximum size of page table entry possible? It is nothing but 4 KB, right? Fine.